taken the valve tester apart. The plan is to make a some form of step-down transformer or auto transformer to run this on UK mains. Obviously it's only got a single tapping for 115 volts for the States. What I've come up with is fitting this power supply at the moment, this transformer here. This transformer's out of an old Heidenhain CNC controller, and what I'm using is as an auto transformer. We're not going to use the secondaries, we're not worried about those. We're going to use the primary windings to tap off to give the 115 volts. So the plan is to mount this into the cabinet. Once I've got that mounted, connect it all up, check to make sure we get the correct line voltage, and we can adjust the line voltage to the variable potentiometer just here. So that's the rheostat, I suppose its proper term is. Get the right voltage, and then once that's mounted, I'm going to try and mount an IEC connector in the back, because normally on these Conars the output connection is through the top there. You see that grommet here, this grommet hole here, and that's fine if you've got a US style plug, but the British plugs have got 3 pins and you can't close the lid down. And I don't like cables flapping around inside bits of equipment as well, so that's a modification I want to do, is mount that in the back somewhere here, so we've got a nice IEC plug and it's all sort of tidily put away. The other modification I'm going to also add to this, and it's worth doing on anything with these moving coil meters, is I'm going to put either a germanium or possibly a Schottky diode across the lead movement. I'll have to check to make sure I get full scale deflection still, but that basically what that will do is it will, if there's a fault with anything or too much current's passed into the meter, rather than burning the meter out, it will protect the meter from a gross overload. I mean, basically anything else on here can probably put up with it, but the meter is the one piece of instrument that won't put up with a large amount of current. And it will also be a good idea to possibly put a capacitor across there, as long as it doesn't affect the response of the meter, because what that will do is that slugs the response of the meter down considerably. And what that allows you to do is, if you've got a sudden short and the meter wangs over to one side, and it can actually mechanically damage the meter. If you've got a capacitor, you've got a slow movement across the scale, and you can see that there's something wrong and turn it off before it does any damage, and you don't get that large inertia swing of the meter pegging against the end stop and bending all the needles. I'm sure we've all seen and probably all done it with a old analog meter where you've plugged it into the mains or something, and it's you've got it on the 5 volt scale and you're on 240 volts, it just clonks off the end of the scale. Actually, that was quite a good invention that Avo used, the Avo 8 particularly, but all the models, the Avo 8, I think they perfected it in the Avo 8, it was a travel limiter, and if the meter hit the end stop too hard, it would actually trip on the in the mechanism of the meter, and actually release the voltage to the meter. So that was quite a good protection. I remember the first week I was working at work, I was asked to do a test on a power supply, and I was given an Avo meter, and I was a little bit unsure what I was doing, and I plugged in this Avo meter to the mains, and I thought I had it in the volts range. And it wasn't, it was on the 10 amps range, and I applied power, and all that happened was the glass of the meter just went absolutely black and silver, and had to explain, and rather embarrassing, that I'd just trashed their £500 voltmeter. Anyway, I still had my job, so I couldn't have been all that bad. Anyway, this is let's see how we get on with this. We'll get this fitted and then we'll move on to the putting in the IEC socket. Right, the step-down transformer is mounted into the box properly now. We're using it in a auto transformer mode, so there's a secondary there, is wrapped up, not doing anything. And we're just using the primary of the transformer to step the voltage down for this transformer that will only work at 115 volts. As you can see, I put an inline fuse in there as well. Even though it does have a fuse for the main piece of equipment, this is really to protect the auto transformer if there's a short on the winding or anything goes wrong. It's a 1.6 amp fuse, which should be fine. I fitted a IEC socket in the side, as you see here, and that's makes it easier, so you don't have a lead inside the lid or the cable rattling around, which would have been impractical anyway, because the 13 amp plug doesn't fit underneath the cover. It's you can't get the lid on. So that's a helpful sort of achievement and improvement. It's got a capacitor here, a 3300 microfarad 6.3 volt cap I'm winding parallel with the meter, and what that does is it just slugs the movement of the meter. The reason for that is when you don't suddenly get one of those big sharp full scale deflections that can happen if there's a short with the instrument and mechanically damage the meter, that will snub the voltage and slowly bring it across, so you'll be able to see it coming across quickly and be able to react in time without it putting a lot of inertial force on the meter and damaging the meter. So that's basically in parallel with the meter. Also, I will add at some point, I think, a germanium diode or a low voltage drop diode across the meter to protect the meters from over voltage protection. Something like I don't know, a small germanium diode. Silicons, the trouble is, have got too high a voltage drop, or a Schottky diode maybe, just to keep the meter protected. So that will be probably a later addition. On the safety front, I did notice that this potentiometer here is takes the primary of the mains and feeds it to the two windings of the transformer on the primary. So this has got mains voltage on it, albeit through this transformer, so you are in fact isolated from the mains. There is still a risk that if this thing fell apart or something shorted out, it could touch the mains would become in contact with the metal plate of the metal back plate of the piece of equipment, and the whole thing would be live, and you get quite a nasty electric shock. And you can see there it says it's insulated for 300 volts, but that doesn't give me a lot of confidence when you've got something of this age with voltage on terminals like this. You can see that are fairly close, and although the insulation looks okay, you don't know how long the insulation will remain good for. So what I've added is I've also added this yellow wire here, which is actually my earth lead. Obviously the original bit of equipment didn't have an earth lead, and I've grounded the transformer case because that's exposed to metal screws as well, and ran the wire up here to this octal socket here, and that's grounded, so the whole base plate is all at ground potential. So in theory, if anything happens, it would just blow the fuse. So bit of safety, a bit of belt and braces really. I'm not usually worried about safety stuff like that, but when I saw that potentiometer back there, I gave me the heebie-jeebies a bit. I thought if something does fall off there, someone's going to get quite a nasty electric shock. The Welly-gig machine seems to work nicely now, all runs freely. I've managed to adjust the gear up a bit, so that's good. The little selenium rectifier seems to be absolutely fine, so I'm going to leave that. All the switches have been cleaned and everything seems to be ready to go. So I haven't got any valves here. Well, I have got valves here to test, but I haven't got the information I need to tell you which valve is which. So I'm just going to power it up, just trying to see why it won't go back in. It's hooking up on my earth wire, I think. Just get that out of the way. I've only just added these wires, so it's a bit of jiggery-pokery to get it all to fit. Now, it should be a lot safer, basically, this piece of equipment. Now I feel a bit happier about someone using it with that earth connection on. So if I plug the mains in, you'll probably be able to see straight away the meter doesn't come up sharply like it used to. So I switch it on, there it comes up nicely damped, and as you see, all the backlights lit up, and everything's working nice and smoothly. It doesn't sound all graty as it did before. So I think it's good. Thanks very much for watching.